So y'all have been doing some research over the past couple days, and you have found the kinetic theory. So an important thing to note is that the kinetic theory is, or gases don't always behave exactly as the kinetic theory states. However, they generally behave close enough so that we can approximate their behavior. So that's what we're going to be doing over the next couple days, is using some equations in order to approximate their behavior. There are 4 factors that we're going to be working with: concentration, temperature, volume, and pressure. So we're going to get into that, starting with Boyle's law. So Boyle's law states that, this is Boyle's law. We have P1, V1, P2 is equal to P2 and V2. So the important thing to note is that P1 and V1 are initial or starting conditions. P2 and V2 represent new or final conditions. So what does that mean? Well, you'll be given a problem where you have an initial set of conditions. They'll say the pressure is this, the volume is this, and then they're going to take that gas and they're going to change it. They're going to say, we're going to change the volume. What will the new pressure be? Okay? Or they're going to say, here's the pressure of the gas, here's the volume of the gas. We're going to change the pressure. Here's the new pressure. What will the new volume be? Okay? So an important thing to note is what's happening to these. So pressure and volume are being multiplied by one another. So remembering back to when we talked about density, you need to know if Boyle's law and pressure and volume are inversely proportional to one another, or if they're directly proportional to one another. So if they're being multiplied by one another, are they directly or indirectly? Since you're not sitting right in front of me, I will go ahead and tell you that if they're being multiplied by one another, they are going to be inversely or indirectly proportional. So if I have pressure on one axis and volume on the other, they're indirectly, which means this one goes up, the other goes down. All right. So Boyle's law states that pressure and volume are inversely proportional to one another when temperature is constant. So you need to remember this graph as we go forward with doing problems. It's an easy way to check your answer. Meaning, if you have an initial set of conditions, pressure and volume, and they say that your volume increases, then your pressure should be lower than the initial pressure. Okay? Or if you're given an initial set of conditions of pressure and volume, and they say your pressure increases, and you're solving for volume, then your volume should decrease. Okay? So these are indirectly proportional to one another. Easy way to check your answers. So we're going to go through with a couple of problems right now. Our first problem, the volume of a gas is, I cannot find my eraser. Volume of a gas at 99 kPa is 300 milliliters. If the pressure is increased to 188 kPa, what will be the new volume? So I'm going to set up my formula. P1 V1 equals P2 V2. A great way to know that this is a Boyle's law problem, I'm going to go back to the last slide, is I am only given pressures and volumes. I was not given a temperature. Okay? If you are either not given a temperature or you are given the same temperature 2 times, that means that temperature is constant. So Boyle's law, temperature is held constant, pressure and volume are what is changing. and they are changing inversely proportional to one another. All right, so back to our problem. So it says the volume of a gas is 99 kPa and is held at 300 milliliters. If the pressure is increased to 188 kPa, what will be the new volume? All right, one thing that can get a little confusing about these problems, kind of straightforward in this problem, but can get a little confusing is where do I put the P1, the V1, the P2, and the V2? All right, so I'm going to underline everything that I'm given, okay? I'm going to assign things over here. P1, V1, P2, and V2. P1, it says the volume of a gas at 99 kPa is 300 milliliters. Then it tells me pressure increases. Okay, so that tells me that my P2, because it tells me that it's increasing, is 188 kPa. So that tells me that my P1 is 99 kPa. V1 is going to be the volume where it's held at my P1, 300 milliliters. I do not need to convert that to liters. As long as it's in a volume, I'm good to go. All right, I am solving for V2. It asks me what is the new volume. New volume is V2. All right, so I have all my variables right now. I want to solve this using variables, meaning I'm going to rearrange my equation so that I'm left with V2 by itself. In order to do that, I need to divide both sides by P2. So now I'm left with an equation that looks like this. And now I can plug everything in. Make sure that you plug the correct variables into the correct place. So P1, 99 kPa. V1, 300 milliliters. P2, 188 kPa. And my V2. Now we can plug this into the calculator. When you plug it into your calculator, make sure that you are either putting parentheses around 99 times 300. So basically make sure that you're doing order of operations correctly. I do 99 times 300 and then I divide by 188. Since we're doing multiplication and division, it actually shouldn't matter in this problem, but it will matter going forward. And I get 157.978, so I'm going to round that to 0.98. And you might be wondering, well, what are my units? My kPa's cancel. I'll be left with milliliters. Is milliliters correct? Well, I'm looking for a volume. Is milliliters a unit of volume? It is. So I'm good to go. All right, moving on to the next problem. Pressure in, I'll erase everything first. pressure in a 2.5 liter container is 1.5 atmospheres. What is the pressure if the sample is transferred to a 6.5 liter container? Alright, so before you start this problem, you again want to figure out what kind of problem you're doing. So far we've only learned Boyle's law, but eventually you're going to learn several other gas law equations. So I recommend writing down what variables you have. So I've got 6.5 liters. Liters are a volume. Oh, and that doesn't, I'm going to write that down a little bit lower. 2.5 is the first one given. 1.5 atmospheres. And atmospheres are a unit of pressure. And it wants to know what is the new pressure. And it doesn't say new pressure. It says what is the pressure when it's transferred to a 6.5 liter container. So I don't know that pressure. I want to make sure that I have these written. Notice that I haven't written ones or twos next to them. Okay? But also, I've written out my variables. I don't have a temperature. So that's a good indication that I have a Boyle's law problem. So I'm going to write out Boyle's law. P1 V1 equals P2 V2. And it says the pressure in a container is this. So these are going to be my V1 and my P1. Then it says it's transferred. So that's my new move. That's my new volume. And it wants to know the pressure in that new volume. So that's going to be my P2. Alright. So I'm going to try to find the P2. Just like in our last problem, I want to solve using variables, meaning I'm going to rearrange my equation. So I'm going to divide both sides, in this case, by V2. So I'm going to end up with the rearranged equation of P2 is equal to P1, V1 over V2. And now I can plug all the variables that I know in. So I have P2 is equal to P1, which is 1.5 atmospheres, multiplied by V1 is 2.5 liters, and divided by V2 is 6.5 liters. And before we get our answer this time, we want to make sure that our units are correct. Liters cancel with liters. I'll be left with atmospheres. Is that correct? Well, I want pressure. Atmospheres are a unit of pressure, so I'll be good to go. Pressure 2, 1.5 multiplied by 2.5 divided by 6.5 is equal to 0.5769, so I'll get 0.577. And my units are atmospheres. If you're not sure about that answer, remember back to what we talked about in the beginning. This is an inverse proportion. As one variable increases, remember our volume was increasing, the pressure should decrease. So volume went up, pressure went down. Okay? So our pressure went from 1.5 to 0.577. All right. And that's it for Boyle's law.